Column 2 tells something about the circuit quantities. Match the entries in column 2 with entries of column 1. So let me read. In all the circuits except in one, switch S remains closed for long time and then it is opened at t equals 0. While for this is what? Situation question is incomplete. I'll search it. Wait a minute. It is opened at t equals 0 while for
1 the situation is reversed.
In all circuits except one, the switch is reverse. This is 1, no? I think I'm unable to see it. Then okay. Okay, now read it. In all circuits, so first we'll do one thing. Third and fourth, second, third, fourth we'll discuss. In all circuits except one, switch S remains closed for a long time, then I'll open it. So let's see that. T equal to infinity, I'll open it. Then what will happen to it? Will there be any spark generated or not? So now there's a path for the current to flow here, no? What all flux is there? There's a path for the current to flow. The current will take a path like this. So any spark will be generated here, no spark. Induced EMF can be greater than E. So induced EMF will be less than E, no? Because the flux will change gradually here because there is a path for the current to flow through the resistor R. So induced EMF would be less than E. So this VL, what is induced EMF across the inductor? Call that as VL. So VL will be less than E. I'll write all here. Space is needed, no? Final energy stored in inductor will be 0 as it is. So what all we can pick up for 2 I can pick up. EMF induced will be less than E because VL will be less than E. So B I'll pick up. Final energy stored in inductor. Okay, some of you are getting confused with this. I'll erase this here. Okay, now EMF induced would be less than E. Then after that, final energy stored in inductor is 0. Yes, it must be. Because after total energy of the coil will be given to resistor R. Final energy stored in inductor is non-zero. That cannot happen. Induced EMF can be greater than E. Not possible. Okay, let's come for the third diagram. Third diagram is now here there'll be a flux or energy in the inductor. So you can write UL, this UL. Finally, no. So there will be a spark generated here. So even cell is there. Yes, irrespective because there's no path for the current to flow. No. So what happened to all the energy in the inductor will collapse within 3-4 milliseconds, what happens? The energy will vanish. Energy vanishes in sense will be converted as EM wave across this open circuit here. So here, so what about the EMF generated here? This VL. VL will be very much greater than E. Then only the spark will be generated. Means don't think that all circuit spark will be generated. For that, what happen? This EMF is of 10 volt. No, here it can be 100, 200, and if the breakdown occurs here, then only spark will be generated. All RL circuits, when you open switch, may not generate spark. At your level, so what happen? What you can say that yes, it is possible in all cases, but practically what happen? All will not generate because if breakdown should occur, no, the energy in the coil should be such that it should make the potential difference across the coil should be such that it should make the A to break down here. There's a practical thing, sir. So I think at our level, we will say that a spark will be generated. So when you go for Olympiad exams, no, they will test you with this one. The potential difference across the coil generated should be such that it should be able to produce breakdown in the gap. Then only spark will be generated. No, for 3, what are the options we can pick up? Induced EMF can be greater than E. Option A, possible. Final energy stored in inductor is 0 because all will be converted here. Final energy stored in inductor is non-zero. Now all the energy of the inductor will be converted as EM wave. The fourth option. There will be some energy present in the inductor initially. UL. I'm going to open this switch. Again, anything, because we are not providing path for the current to flow here. There will be a flow of current in across the resistor, but what happens? The energy across the inductor, it should be given out. So therefore, here a spark will be generated. Then the drop across the inductor will be very much greater than E. So the fourth one, E, induced final energy stored inductor will be 0. Okay, this is about 2, 3, 4. What about the option 1? Option 1 is it is like this. I'm going to close the switch. It is open. I'm going to close the switch. I'll discuss above here. No, option 1 will take this one. Option 1, what is the condition? It's a reverse, no? The switch is open. We have a resistor. There's an inductor. Now there will be a energy will be there in the coil. So now I'm going to close the switch. So once if I close the switch, so what will happen to inductor now? It will discharge, this cell will be shorted and the current will flow like this here only. So what all drop generated, VL will be less than E. And finally the energy across the inductor will become 0. For the first one, induced EMF would be less than E. Final energy stored in inductor is 0. All the energy will be taken by the resistor R. All RL circuits will not generate, but at our level, anywhere you see that the in RL circuit, so when inductor is unable to pass current through the circuit. In that case, what the energy in the coil will be converted into, so like a EM wave, that one in the gap, not in the spark will not be generated